Okay, so I'm gonna thank you, Charles, for being with us. I'm gonna introduce him and then pass the mic to you so that you can share with the group your experience. So Charles is the founder and the chief scientist for calculation consulting, helping companies specializing in machine learning and data science. He received his PhD in chemistry from the University of Chicago, and he has devoted 30 years of his life to the academic study and business practice of numerical scientific computation. So as you have heard, he's an expert on AI and machine learning, and his talk is going to focus on how AI and machine learning is applied to the lean startup. Hopefully you like it, and thank you, Charles, for being with us. Thank you.
Okay, thank you. So here's just a little demo of who we are. I think we've sort of gone through that. So what I'd like to do today is first talk about what do we mean by an AI startup. So if you look back in time from, say, 2010 to 2014 or so, most of the AI work going on was research-oriented. For example, Google acquired DeepMind in 2014, which is really what kicked off the AI wave that we're now all in. Somewhat later, so in the first part of the decade, a lot of the AI was very research-driven. After 2014, maybe 2016 or so, we started seeing the development of machine learning and AI infrastructure. So I've put a couple startups on here, but also you have things like Amazon recognition APIs and Microsoft Azure. It's at a point now where machine learning has become completely commoditized, and it's really capable, it's really able for startups to access machine learning either through APIs or through open source tools and be able to start building products. So starting now, in 2018 or so, we're now starting to see the development of applied AI companies, really companies that are verticals, that are focusing on how to use AI as part of their core product, or various kinds of horizontal platforms that are helping companies, enabling AI for companies. And even seeing now full stack companies where AI is at the core, and basically companies that are rebuilding entire industries with AI from the beginning. What I'd like to start off today is talk about a couple of startups I worked with way back in 2010 that were doing machine learning even then. So this is even predates some of the AI craze we're in. One of them is Aardvark. And Aardvark was a machine learning startup. It was a social search engine acquired by Google in 2010 for $50 million. And the other is Demand Media. And Demand Media was an AI-enabled IPO. It was the first billion-dollar IPO since Google. And both of these companies used machine learning and some early forms of AI and were very successful. And so what I want to point out, but at that time it was more difficult. You had to have PhDs. You really had to know this stuff very well. And I think now with the machine learning infrastructure in place, a lot of the things that we were doing, even way back in 2010, are now becoming widely adopted by hundreds and hundreds of AI companies. So sort of the overview of the talk, this originally was an hour talk, so I'm going to have to cut it back a little. I first want to talk about the difference between what is a lean startup and a fat startup, since I'm here talking about lean startups today. And by a lean startup, what I mean is, in 2008, the market crashed. We had a huge market crash, so money was very tight. And this is the time when lean startups were very, very successful. In fact, I can tell you, I talked to one of the top investors in the Valley at that time, and she said to me, all the VCs are going to stop funding. And I was at Aardvark at the time, and I'm like, oh, that's not good. But amazingly, Aardvark survived pretty well. But at that time, money was very, very tight. And so you had to be very lean and very scrappy in order to do this stuff. Now it's 2018, the market is booming. There are lots, and I think there are $35 billion tech companies, tech startups here in the Bay Area. And so the funding has become much, much more ambitious. I have people coming to me wanting to do projects, and they're saying things to me like, well, we want to raise a $5 million, and you mean an A round? He goes, no, we want to raise a $5 million seed round. Because that's incredible, compared to what we were doing 10 years ago. So I want to sort of compare and contrast how you apply machine learning and AI when you have different kind of funding situations. So the example would be with Google, with Aardvark, which was acquired by Google. This was a company started by some ex-Googlers. They were actually a prototype of the Lean Startup. Has anyone here ever read the book, The Lean Startup? So I don't know if you've seen the website. Aardvark is actually one of the case studies that were featured. So one of the things I can talk about, I'll probably talk about more in private than in the talks, what they actually sell as the Lean Startup and what we actually did. Because when you see how the sausage is made, you have a little different perspective. But I mean, it was extremely successful and it was acquired very, very fast at a time when funding was extremely tight. And in comparison, I would talk about Demand Media, which was a unicorn. This is what my staff guys apparently is called a brony. Apparently, I don't know about My Little Pony, but this is the unicorn, My Little Pony, who's very wealthy. And I bring this up because Demand Media was started by the ex-chairman of MySpace, Richard Rosenblatt. And so they had huge amounts of funding, just as much funding as you could possibly imagine. And they were, in fact, a billion-dollar unicorn. By definition, but the first one, and the ability to drive into get the IPO done was actually done by using AI and machine learning. So I sort of want to compare and contrast these two startups as sort of an understanding of how you can apply machine learning in your startup. So what was Aardvark? Aardvark was a social search engine. The idea was I don't know if anyone used Aardvark, maybe probably half of you were in high school when Aardvark was around, but the idea was it was running on a chat client, and you would ask it a question. So you might ask it a question like, what's a great biking path around the Golden Gate Park here in San Francisco? And Aardvark would go out and find someone on the internet, on the network, to answer that question. And you could get the question in just a few minutes. And so the answer, like my favorite secret trail is the one that goes to the beach. So this is what Aardvark was. It was a social search engine. It was a Q&A site. Demand Media was also a Q&A site. Have you guys ever used, we may remember eHow.com, which at one point was one of the top 10 or 20 websites in the world. So that's Demand Media. And now I think they're called Leaf Group. But eHow at one point was a huge, in fact, I think at one point we had, I don't know, maybe 70% of all common long-tail Google searches. And in fact, there was a very famous article that came out called The Answer Factory in Wired magazine. It was really a big deal back then. So it was also a Q&A site similar to Aardvark, but used machine learning in a very different way. And I said this is the first billion-dollar IPO since Google. In fact, it was so successful that there were some articles about Richard Rosenblatt had this yacht that I think was called the AdSense. And this was a huge scandal that he had this yacht. I'm not even clear. It wasn't really clear to me how bad this was for Google, but there was an old story about how one of the top guys at Google went out and spent 2 weeks in the Caribbean with Richard on his yacht, and the huge amount of money that Demand Media was making for Google at the time. So this was a really good example of a company that was just flush with cash. Now the problem was the IPO crashed. And what happened was, in this situation, we were using machine learning algorithms for eHow, and we were able to essentially predict what people wanted to search with on Google. And at that time, Google was, the situation with Google was very different. And if any of you do any of you do SEO for driving traffic? And you may know about something called Panda. That was implemented. This was why Panda was implemented. Panda was implemented because of how we applied machine learning at eHow. We essentially figured out how to predict what people would search for on Google. And by doing that, you could front run all the SEO and pretty much generate as much traffic if you wanted. So this was a very good example of how you have these machine learning algorithms. They gave you tremendous scale, hyper growth, growing very, very fast, but you really didn't predict what was going to happen with the algorithms. The comparison is that Aardvark is a company where you use machine learning to find users to answer questions. So you're able to use machine learning to drive adoption. It was designed in a way to make the user experience really, really great. So by having machine learning, you could get people to really find the right questions. You could engage with great conversations, and it was a very, very effective tool. But it was not a machine learning company. Aardvark was a social search engine. And in fact, it didn't start out with machine learning. It started out, in fact, all doing Mechanical Turk, all by humans. And the machine learning came later. It was really the machine learning that drove the adoption later in the life cycle after they found the product market fit. Likewise with Demand Media was not an AI company. Demand Media was essentially an answer factory. They had this algorithms that would generate what people wanted to search for. But it was much later, after they had made the investments, after they had collected huge amounts of proprietary data, that they were able to apply AI and drive SEO. So sort of the takeaway here is, whether you're small or whether you're large, the machine learning comes later. First, you find the product market fit, and then you can apply AI or machine learning to drive adoption, to drive SEO, to drive revenue, to improve customer engagement, et cetera. So here's an example of, in fact, in this example of how the funding situation has changed for startups. And again, to me, this is just really amazing that you have seed rounds of 2 to 5 million, a Series A of 5 to 50 million, which 10 years ago was unheard of. But in terms of, and I took this from a TechCrunch article on some VCs that were looking at SAS startups. But if you look at things like what is expected in terms of the data strategy. Once you have your seed round, the first thing you'd be expected to do is to collect unique data. Especially if you're something like a vertical startup, it's really the unique data that's going to give you your defensible position. So you really want to find ways to collect that data and make sure the data is good. And really, it doesn't come into the second stage, maybe when you get your Series A, that you start putting machine learning models into production. And so if you have a startup that maybe is more technically focused, you might be doing this. But I think the intent here is that it's not the machine learning algorithms themselves that are going to give you your defensible IP. It's how you combine them with your unique data, and after you have your good product market fit. And then it's much later in the Series B that you start seeing people expecting that on the engineering team. You start building out ML infrastructure. You start bringing in very experienced machine learning engineers and scientists. This is expected to happen later. So early in your life cycle, you don't necessarily have to do that. In fact, the point is that you can really leverage the existing machine learning infrastructure to do this. And and I think this is true whether you're in a very, very lean startup, which has only a very small amount of money, or even in a startup that really you can raise quite a bit of money. That the machine learning is something that for a lot of people is thought of as an enabler, and it's core to your business, but it's not as defensible as it might seem. So I'll give you an example by talking about what I mean by a lean startup and what sort of the engineering management of this. So there are a lot of models for how to manage a development process. Rapid application, software, the Scrum, Agile. I'm told that in France they used to teach the V model. I don't know, is that true? Did people study the V model in engineering? Okay, so my staff guy said, when I was in France, so the V model. So I don't know the V model. I know like things like waterfall models. This is something for me, V means very large. Something that's good for very large projects. Not something you would do in a startup. In a startup, we have the lean startup model. So this is a very famous idea. And in the lean startup, the idea is you have an idea, you create an idea, you formulate a hypothesis. Then you create a minimal viable product. And with Aardvark, this was like 1 month. Can you create a minimal viable product in 1 month? Then you test that product on customers, and then you try to learn from those customers and fine-tune and redefine the hypothesis. So with the Aardvark guys in the lean startup, they talk about how they spent 6 months and built 6 different minimal viable products. All of those products, though, were not just random things. They were all focused in social search. They were all about finding ways to improve search. And they stumbled upon Aardvark within that process. So part of this, you're trying to figure out what your product market fit is. So where does the machine learning fit in to this? Well, let me give you an example of how the cycle developed and how you use these sort of learning cycles in this process to figure out how to do machine learning. And one of the interactions, we were building this product, and we used to ask the users, someone asked a question, and like where's a good place to go hiking? And they might say, well, I like hiking to the beach. And then we'd ask them, did you like the answer to this question? And then we'd go Vark. And they would type Vark. Vark meant yes, I liked it. And so that we had this in the original version of Aardvark. And in fact, Aardvark didn't have machine learning in the beginning. It just had humans who were doing the routing. So we didn't even have any machine learning in the system yet. You had someone, you'd ask a question, there'd be some tech guy doing the routing, and he would find it. And then we went and we asked the users, what do you think about this feature? So we really don't like this feature. And you know, from an engineering perspective, if you're a machine learning guy, you understand what I'm talking about. If you have the VARC, that gives you supervised feedback. So it makes the algorithm much easier, it makes the engineering much easier. But from a product perspective, it wasn't a good idea. And I remember at the time, like, oh, we're going to take this out. Well, now my life got a lot harder because now you have to do implicit feedback. You have to read the text of the conversation. And you have to figure out, was this a conversation, a good conversation, or a bad conversation? And so from an engineering perspective, it made it harder. But from a product perspective, this is what people liked. And so this was what I meant by this cycle of learning. You know, we would, especially in the machine learning context, and trying to focus on the idea that even though you're doing machine learning or AI, you're really focusing on the product. And you don't want the engineering to drive the product. You want the product to drive the engineering. So in practice, when you're talking about doing machine learning and you're doing the lean startup model, in this case for Aardvark, we were looking at a very broad search space and finding new tools that could be used to implement new ways of doing search. The earlier customer interactions were not machine-based at all. In fact, they had this saying called fake it till you make it, meaning that you would fake the machine learning. You would have humans that would pretend to be doing the AI. And in fact, even though we were doing this in 2010, this is very, very common today. You know, I think if you went to Accenture, I don't know that for sure, you know, or some other company, and you had them build you a chatbot, you might find out that the chatbot is actually a bunch of guys in another country interacting with you. It's not actually AI. But they're telling you it's AI. Well, that's what we did. We pretended it to be AI. And I would say even today, like, you know, in 2010 also, I sort of say the Aardvark, they had to do this. They didn't know how to do the machine learning. So it was very hard. I mean, it took weeks to do what you could do in a couple weeks today. So it was really hard. So you probably could put some basic machine learning in place today, but it's not going to be as good as you think. What you're trying to improve is not the algorithm. You're trying to improve the user experience. So there's this thing called Wizard of Oz testing. Has everyone here seen the Wizard of Oz? I was told you may not have seen it. So there's a spoiler alert. I'm going to tell you the end of the Wizard of Oz. There's a wizard. And the wizard, there's this wizard, they go and try to find the wizard. They have to go and meet the wizard. But the wizard is actually a guy behind a screen. He's not actually a wizard. He's got these machines. So there's this thing called Wizard of Oz testing. It actually is a real thing in human-computer interaction. And the idea is that when you're building a product that's interacting with humans, you want to intercept all the communications between the user and the system. And then you want to simulate the response in real time, so that you can run live experiments. And then you learn from user feedback. And there's a very famous, it was famous, you know, maybe 20 years ago, a guy, Cliff Nass at Stanford, where he wrote a book called The Media Equation, where he talks about how when humans interact, even over a chatbot, they think they're interacting with a person. You know, they get angry and they interact in weird ways. That's why people flame each other. They go crazy. You know, they think there's a person on the other side, but it's not. In this case, it is a person. But you know, when they interact with your system, they're going to expect it to interact like a person. And if they don't have that kind of interaction, they become very upset. So it's your job to try to figure out how to get the AI to do that. And that's going to be true in any product you're making that's customer facing. So what does this have to do? How would you actually do this if you were in a startup? Well, we have this plot. If you've ever watched the Lean Startup and you've seen some of the demos, this is right out of the Aardvark case study. You start off with a system where you have full human judgments. The people are chatting on the thing, you have full human judgments, and the humans are interacting with you in your chatbot. And what you do is you implement your machine learning in such a way that it will suggest things to the humans. And they can just like you'd make a trading system and you might suggest you trade. The machine learning algorithm will make suggestions and the humans will look at it and go, okay, I think this is good, I think this is bad, okay, I'll do this, maybe I won't. And typically you have, you know, in a seed round or, you know, in an A round, you have maybe 12 to 18 months of runway in a startup. So at some point, the machine learning or the AI has to become good enough that the humans can just act. Does this pointer work? Oh, I should have done that. That the humans can just act without that the machine can just act without human approval. And this line has to cross in about 9 months. So you've got about 9 months to figure out how to get your humans out of the loop, at least for a bulk of the system, so that you can at least have the machine working, and then the humans are just sort of acting on the system, and they're saying, okay, this is good. They're only intervening if there's a problem. And then, you know, by the time your product is ready to go and you're going your Series B, you want to be fully automated to the extent that you can. So this is the idea of how to do lean machine learning. And this is exactly what we did at Aardvark. And I think for a lot of products, if you're trying to do AI and you're wondering, how am I going to do this? How am I going to implement AI in production? You know, do I need to hire a bunch of data scientists? We're a consulting firm, so we're happy to help you. But really what we tell you is you don't want to try to build some super highly accurate system from day one, because it's not going to, you're never going to get 100% accuracy. If you get 90% accuracy, it'd be phenomenal. You've got to have something where humans can intervene and where you can incrementally improve the system. And you have to have systems that work like this. We had a client once, come to me, they want to build this legal application. And they said to me, well, we want the thing to be 95% accurate. But for the other 5%, we have to go and have a human review the legal documents. I go, well, yeah, but you have to know which 5% it makes the error on. If you don't know which 5% it makes the error on, then you have to review every single document. And if you don't know with confidence, you might be reviewing half of them. So, so it's very important to understand when you start building an AI into your system that you understand what its limitations are. You can have humans interact with it. You know, you don't want the self-driving car to just be, you got to be able to grab the steering wheel, otherwise you're going to have a real problem. Now, the comparison of this is what a lot of we see today, especially with enterprise clients, is let's say you have a lot of money and you can collect a huge amount of data. So how did EHAL do this? So I told you I was going to compare Aardvark to EHAL. EHAL did this by just creating huge amounts of content. By the way, if you ever use Google, what do you think the #1 search is on Google? The #1 long tail search, like with five words or so. Question, what's the #1 question? Take a guess. Moms in Iowa, moms in the Midwest, what would they ask about? How to get rid of flabby arms. How to get rid of flabby arms. You know, flabby arms. That's the number. That was the #1. That was our big seller. So you create a whole bunch of articles on how to get rid of flabby arms and all sorts of other articles, and then what we did. So you have a huge amount of data. You go and you get your data. So what I'm saying is, imagine you're in a company. You go and you get your data, and what EHAL did, well, we generate a huge number of pages, and then we would collect the inbound search traffic, so we knew what people were searching for. Then, since we knew what people were searching for, we could predict what they would ask, create evergreen content, and now all results are EHAL results. And that's exactly what happened. Well, if you know what happened with Panda, you can't get the inbound search traffic anymore. They turned that off. But you used to be able to. So you have to be very careful. When you're doing machine learning, you go out, you collect a huge amount of data, and you say, oh, I've got all this data, I've collected all the data, I put it in Hadoop, I'm ready to go. And even though your algorithm might work, you might find out that things change. And you weren't expecting it. And especially if you're working with somebody else's data, somebody else has collected. There'll be another example which is a little more practical. Today, I read an article about some guys at a hospital. They had developed some sort of medical imaging machine learning algorithm. Maybe it was to detect lung cancer or something like this. And it worked at their hospital. And then when they tried it on another data set in another hospital, it fell out completely. So something happened, in the collection of the data. It was probably, the people who had lung cancer, the data was probably collected slightly differently than the people who did not. And because you did not collect the data and you don't have control over how it was collected, you built this machine learning algorithm, you spend all this money, you spend 18 months doing all this research, you obviously there's product market fit, everyone wants to know, but then it breaks down. So whenever you're implementing machine learning, you have these kinds of problems that when you interact with, you're using data, you have to have this constant feedback loop. You have to and you have to try to anticipate what the risk is going to be. So we're almost done here. So I was going to talk a little bit about the types of startups that exist. We can talk about this offline. I'm going to end and various kinds of what the funding looks like for verticals. But I'm going to end with some of the soft skills. Excuse me? I'm sorry. Well, Batman. Well, that's, you know, what I'll start with. Well, one of the things you do when you're hiring, have you ever watched the show Big Bang Theory? Okay, so I used to be a theoretical physicist. I was Sheldon. And it's a very scary thing to think about. But there are three types. Not all techies are. A lot of people using software. Techies are different. Not all techies are the same. So when you're dealing with AI people, you have a lot of Sheldon guys, a lot of PhDs. They're used to they work by themselves. They're a little goofy. They don't have a lot of human interaction. Then you have the Howards of the world, you know, who are the ones who cause all these diversity problems that you have. You know, they do all sorts of goofy things that they really shouldn't be doing. You know, but they're software engineers, browser tech, DevOps. They're software engineers. Data scientists are more like Leonard. You know, Leonard's more the normal one. He can interact with people. He has is a sort of a more normal. He's the more normal of the three. And the point I'm trying to make here is that, you know, not all techies are the same. And so when you try to build a team, you're organizing a company, you're trying to build a team, you're going to realize you're going to get different people. There's a lot of diversity just within the types of engineers and scientists that you hire, and you have to be prepared for this because you're going to find out that hiring someone who's a software engineer and has 10 years of experience in industry is very different than hiring someone fresh out of school who has a PhD who spent the past 5 years working by himself and not interacting with no one else except his advisor. So this is a critical thing to us in hiring. So I think you know the kind of person you need. You know, like, if I'm a founder, I don't have like machine learning experience. So the question is, how do you know what kind of person to hire? Well, you know, it's really important to have someone at the senior level who is either an advisor or an executive position who can really help you with this, because you know it is very hard. And we had a client once came to us. They hired a mathematician from Harvard. They spent a year with him. Nothing got produced. Nothing. You know, within 3 months, we had revenue up 30%. But you just didn't know. So, and it just, you know, if you don't have, you know, if you're doing an AI company today, and AI is core to what you're doing, machine learning, you've got to have someone in a leadership position, even if it's just a consulting person, who can help you understand this. So I wanted to end with this notion that if you're going to work with Americans, that the Americans and the French are very, very different. And you may notice this by, you know, my understanding that French are, I have a French staff, very, very logical, very calm, you know, very much what we would call is kind of like Spock, you know, very logical, very easy to deal with. Americans, on the other hand, when you work with them, they're very loud, and they'll provoke you. And you may not realize that when they provoke you, they're trying to communicate with you. So here's a good example. And you may not realize they understand this. But in the US, when someone's fighting with you, they're actually communicating with you. So the point is that, you know, we all want to work together. And, you know, when you're working with different kinds of people, especially, you know, these different kinds of engineers, different kind of techies, you know, it takes a little bit of patience, but you can really do some pretty amazing things if you're doing AI. So I will, now we have 30 minutes, so I open up to questions. Do you want to do them like this or one-on-one, whatever you guys want to do?
What can we learn from Batman?
Oh, you wanted the Batman slide. So there's a, I can find it. I passed it. So this is I was going to talk about lessons I have from consulting. And when you're doing consulting, you're really trying to help people incrementally. You're not really being disruptive. You're not really, you know, you're not trying to create a vertical. You're really kind of like Robin. You know, you're a sidekick as a consultant. When you go into a company, you know, especially if you're an AI startup, and I've seen this quite a bit. You might go in and you have some sort of horizontal product. You know, you built a new kind of platform to replace Hadoop or Spark, and you go in and you give it to the company, and the company wants you to develop something on it. But what the company is expecting is a pilot. They're not expecting to spend 18 months of research. They're expecting you to give a pilot. So you've got to start developing some sort of incremental improvement for them. So an example might be, you might decide, oh, I want to start getting consulting services. We'll sell consulting services as a startup. You can implement something like a recommender. We've had cases we've implemented a recommender, and you can get 30% gain. 30% gain in 30 days. You know, money not guaranteed, no money back guarantee. But it does work. You can get really fast. If you go in and you implement some simple machine learning, especially if you're going from 0 to 1, you can get really great gains. The problem if you're a startup, I do this as a consultant, and as a consultant this makes sense. I can charge a markup, I can give companies big revenue gains, everybody's very happy. As a startup, you have funding. And what happens is when you start doing this, the algorithms you're developing are going to be commoditized in 3 to 5 years. So unless you're trying to find product market fit, you're trying to find some product that you can produce over and over and over again and sell in a vertical or across various industries, what you're really doing is you're basically just offering consulting at below market rate. Maybe you could charge a 3x, a 2x markup. But I don't think your investors want you to get a 2x markup on your revenue. I think they're looking for a little more than that. And unless you are specifically a consulting play, you need to be very careful not to become Robin. You want to be Batman. They're saying if you can be Batman, be Batman. But if you become Robin, you end up just doing these projects on and on and on. You end up doing these engagements. You end up doing one-offs. You never develop your product market fit. And that's the story of Batman and Robin. So I guess I'm Robin. That's what happened. Thank you. Any other questions?
Machine learning is quite often I found an easy way of being lazy and not defining a problem. Which, a lot of people will use machine learning because they don't have the skill to define the problem. It's a very bad solution to find, an easy problem, and it allows a lot of people to put AI on it. Do you think this might impact the people who do true machine learning?
Okay, so the question is, machine learning seems like an easy way to solve a problem when you don't know anything about it. And I would say yes, that's absolutely correct. And what is the impact of the people who do AI? Well, I can tell you the impact on a company is that you end up doing things like implementing spurious features, or you don't understand why something works. So a good example is I used to be a quant at BlackRock. I was a consultant and we developed risk models. And it was recently BlackRock announced that even though they have these risk models that are developed with AI, they're not going to use them because they can't explain why they work. And since you can't explain why they work, and there's no causation, you don't know when they're going to fail. And this is a huge problem. And so if you don't know why something works and you don't know how it's going to fail, it opens up these huge risks. And obviously if if the whole point is it's a risk model, you have to know what's going on. So the problem with machine learning is that, you can have a case where people just put all the features in, you run this automated machine learning, all of a sudden you start doing revenue gains, then something changes and you don't know what happened. And so it's a real challenge. And I think there's especially if you start growing very, very quickly and you don't realize what's going to happen, whether it's internally or whether, as with the eHow case, Google decided to just change all the traffic and then they couldn't, they just got stuck. So I think it's a huge problem, and there are people who know how to do things who understand how to do things like causal models. Statistical causal reasoning, and you have to really decide, does it really matter if I don't know or not, and what will be the impact of this? And that's a very difficult question to assess because, if machine learning starts generating revenue for you, it's difficult to turn that off. Go ahead.
So to put it provocative, do you say black box models have no future?
Do I think black box models have no future? No, I think they're amazing. You can do it. If you look at one of the things we do on the side is I have an engagement with UC Berkeley. We do consulting, try to figure out why deep learning works. Nobody really knows why deep learning works. And if you ask the mathematicians or the computer scientists, they're very puzzled. And yet, I think it's very dangerous to have something like a black box self-driving car. I think it'd be very dangerous. Something that, what's happened is a lot in this machine learning technology that grew up in the Valley, grew up in ad tech. So if you show someone the wrong ad, they just don't click on it. It doesn't matter. And so I think if you have a black box system, you need to be in a space where your product doesn't really matter if you don't know what's happening, or you have some slack. If you really need to know what's going on, you need very high accuracy. I would not use a black box model. Go ahead.
Could you tell us maybe if there are some companies, AI companies, new companies, that have surprised you in a good way?
I'm surprised by all of this. You know, I've been doing this since the 90s, and I think there are hundreds of companies. I mean, here's an example of the average amount raised by AI companies. The fintech space has just gone crazy. A lot of that is things like lending, and there's obviously things going on in insurtech and such. I think it's just amazing what's going on. Every time I turn around in 6 months, there's a change. The things you can do now, for example, in natural language processing, this year, we have not been able to do. We didn't know how to do. There are huge changes just in the past 6 months. I think that I have a client now that we're working with. I joke with him, you know, we could replace 40% of your staff. He says, well, I don't want to grow that fast, you know, because something could go wrong. But I mean, I think that's, I mean, look at things like self-driving cars. That's amazing. Yeah, I don't know if I take it on the road, but I saw a guy who was able to repark his car. You know, you could just move it, you know, so they can't, you know, especially in San Francisco. He logs into his phone, moves his car. So that's amazing. Or, you know, some of the things going on in health diagnostics. I think if they can figure that out, that's phenomenal. You know, the other answer is that there are a number of what are called full stack companies. There are companies that have just gone after, you know, gone after entire industries. So you look at something like Uber. I mean, 10 years ago, if you were doing a startup and you wanted to sell, you wanted to get in the taxi space, you would make taxi software and you'd sell it to the taxi companies. Right? Uber said, what happens if we redesign the taxi from the ground up? And it's essentially an algorithm. I don't know if it's AI, but you know, it's a routing algorithm. And it's incredibly effective. And that is, and they're also very, very good at economic modeling. They have hired all these top economists, which is sort of the opposite of black box modeling. But I'm a physicist, so I route that all in algorithms. And you know, they've basically disrupted the worldwide industry doing this. And that's what's going on now in the Valley, is that people are just, there's a lot of, you know, if you can do it, you can pull it off, and you have AI at the core, you have entire industries are going to be disrupted. Go ahead.
Regarding the artificial intelligence and more super intelligent topic, do you know any startups that are creating kind of super intelligence here?
So the question is, are these startups doing super intelligence, or what would be called, sometimes called artificial general intelligence? Well, I mean, obviously Google DeepMind was doing this. There's a guy, Hawkins, who has a startup. I can never remember the name of it. But there are some startups who are research-oriented like that are trying to solve the problems of how the human brain processes information. So if we touch base, I'll give you a list of my, you know, when you're going off the cuff, it's hard to remember everything. But there are a few here in the Valley. I would comment that a lot of the really good AI research is not coming out of academics anymore. It's coming out of privately funded institutes such as OpenAI. I wouldn't call it a startup, but it's a privately funded institute. The Allen AI, the Allen Institute for AI, OpenAI. There's really phenomenal work going on in some of these privately funded institutes. And you know, one imagines that there would be startups that would be spun off from those, but I think they probably have a 20-year mindset. Go ahead.
Yeah, with your experience in the Valley with different companies and you have a lot of experience in AI, how is hiring here at PhD, you know, for computer vision and this? Because we try to hire some people in Europe for that, exactly.
So the question is, how is hiring for people who have experience in computer vision in the Valley? And the answer is everybody's here. They all came here. You know, I have a lot of friends who are natives of San Francisco, and they say, you know, we're not strange. You're the strange one. We were here first. Yeah, everyone has come here. And if you do computer vision, they're probably here. The challenge is that a lot of the big companies have sucked them up. So Google, Facebook, they're gonna bring them in. They're gonna pay them a lot of money. So you know, $300K or so would probably be normal for people who have good experience. And you know, you've got to compete against that. So you know, there are a lot of people learning this stuff now. I have a friend who works at one of the self-driving car companies, completely self-taught. He was taking this self-driving car class, and I sat in on him and saw what they were doing, and I would kind of help out with the math. And he was an old software engineer. He's tremendous, and he's just been very, very good at dealing with the operational aspects, things like TensorFlow, it doesn't load the data fast enough. We've got to go in and change it, just managing it. And so there are a lot of people who are very, very good who may not necessarily have a PhD in the field, but have just really, they've come here and they've really, you can meet them in the cafe or the coffee shop, everywhere you go, everyone's studying this. And so they are here, but yeah, as with all hiring, it's very, very hard. It's super competitive. But go ahead.
How do you think, I've seen recently things like Google ML. Like, how do you think, AI or developing models is going to be as commoditized as, setting up a server in AWS?
So the question is, how commoditized will machine learning and AI algorithms would be? And what I would say is that anything you're doing now, probably 3 to 5 years from now, will be completely commoditized. And the reason is that the AI, first of all, Google and Amazon and Microsoft have put thousands of engineers on this. So they're just banging along at it. And if you think, oh, I've got this new neural network and it has these features, it's just pretty amazing and I can do this, 2 or 3 years from now, it's going to be completely obsolete. And so I think your competitive advantage is where you have unique proprietary data, where you have product market fit. If you're a sales company, your ability to do sales, in the end, companies are about sales. I have a friend who's a sales person. He sends me every day, he sends me some text telling me about I'm not a good salesman. You gotta be a better salesman, be a better salesman. Because it's all about sales. And I think that the challenge is using the tool properly. And so, no, but I think it's completely commoditized. In fact, I wouldn't want to be in the machine learning infrastructure space. I think that's just, you can go into Amazon right now, or you can go to Amazon or Microsoft Azure, and you can access their APIs. And I think the only thing that might not be commoditized are when you're in something very, very specific. And there just isn't, the market isn't large enough to commoditize. And that could be a warning sign for you. But I think very much, from what we're seeing, it's just getting commoditized faster and faster and faster. Go ahead.
One of the things you talked about, you said value is your data. IBM says that they don't collect your data. Is that true?
IBM says what?
IBM, IBM.
I heard of them, yeah.
They said they don't collect your data. Is that correct?
They do not collect your data.
Yeah, they said that when you use the algorithm, and they do not collect your data.
Well,
would you believe it or not?
Is there some guy at IBM who decided he wanted to collect your data? Let me tell you a story about a client we worked with. And they want us to come in, and we wanted to get access to their Oracle database. And I said, well, okay, do you have a replica of the database? Sure, we have a replica of the database. Okay. Can we have access to the replica? No, you cannot have access to the replica. All right, so we try to get access to the replica. Finally, they give us access to the replica. It's not actually a replica of the database, it's just test data. Go, what good is this? And so, well, you can back up the data. Well, you have to, they gave us this book on how to back up Oracle, 900 pages long of how to back, no wonder Larry Ellison is so wealthy. So we found out, how are you backing up your data? So there was an engineer at the company, and he was doing exactly what I thought we should do. He was running a little JavaScript at home at night, connecting to the network, backing up all the data on his local machine. So, when you're working with anyone else has your data, even though the company policy might be, we're not looking at your data, companies are filled with people. So you have to be concerned, what is the actual, how valuable is your data? Are people really getting access to it? There's been all sorts of controversies, what's going on with Facebook and with Cambridge Analytica and all of this. I can say that a lot of clients we work with are reluctant to be on the cloud because they're concerned the data may not be secure. And you have to ask yourself, well, is your security better than Amazon's? So I think that it's always a risk. The cloud vendors are telling us that eventually storing data will be like electricity that you wouldn't generate yourself. But I think it can be very situation dependent. I saw one over here. Over here. Go ahead.
So, question to our government. Do you think that potential future legislations could be the problem here in Valley? For instance, that some kind of AI could be, not permitted by usage or something
Well, I mean, the most recent legislation I saw was around from the SEC. I think it was the SEC. It was saying, for these risk models, that you have to have very specific regulation around what your risk models can, and they cannot use AI, and if they do, what they have to do. So, I mean, there are regulated industries that require that. I mean, I think that if you start talking about having things like self-driving cars, or other types of autonomous vehicles, or other things that are really autonomous, or certainly in medicine, there's going to have to be some regulation to make sure these things work. And I think that's the concern that people would have. And then the other, of course, is whether they're going to break up the big companies or not, whether big tech's going to stay where it is. In terms of what the government understands, I don't think the government has a really good understanding of AI. I don't think they're at the level that Silicon Valley is. I mean, I don't think they're putting, look at some of these government contractors, I don't think they have 5,000 people working on AI. I mean, I don't know, but that's been my impression of what's going on. And I think there's a lot of concern. I do have some friends in Washington, and there is some concern about the fact, for example, that Chinese are getting so good at facial recognition, and we're nowhere close to that, to what they can do. So there is a lot of that kind of concern. Go ahead.
More overall question, you were talking about the seed and Series A and Series B rounds and the numbers that are spent there.
Yes.
So in 2008, was there a crash, or did it, because in Europe we have much lower seed?
Yeah, I know. I've been working with a private equity firm, and he tells me this stuff. I go, what are you talking about? And I goes, I'm going to go raise $5 million. You're not going to raise $5 million. I'm going to go raise $5 million. Okay, maybe he will. Look, in 2008, there was a market crash. And at that time, there weren't all these unicorns. Like I said, Demand Media was the first billion-dollar IPO, and that occurred in 2011. So back then, funding was necessarily not as crazy as it is now. And when the market crashed, basically, there was just, okay, we've got to start unloading our investments.
So how was it before 2008?
Well, it was much smaller. You didn't have companies like Uber with $50 billion valuations. You didn't have $35 billion startups in the Valley. So it's significantly different than what it was 10 years ago.
Which means now maybe in Europe in 10 years' time it could be like in the US now.
I think so, or you need to be very aware. Look, when they're Valley investors, they're looking for big hits, and if you're not going to be able to provide a huge hit, they basically think, look, I have an investment, I want one or two of my investments to be the big hit, everything else can be a loss, and they want to be huge. And so you have to ask, what kind of investor you're looking for, what is your market size, and is this, you have to find someone who's going to fit that. There are people who are, who, like I said, want to build these full stack companies all built on AI to take over entire industries. I think sometimes it feels like Silicon Valley and the West Coast is waging an economic war on the rest of the country, and just systematically trying to disassemble all the old industries and rebuild them. So it's definitely different. It could be, if the European VCs are very successful, then yes, it could be that in Europe you would see these kinds of very, very large seed rounds and A rounds and B rounds as well. But that's, I think it's something very special to Silicon Valley, maybe to China. I don't know what's going on in Israel. Maybe in Israel you have this because there's such a huge market of startups there. But it's definitely very, very different than it was 10 years ago. Yeah, in the green shirt.
So when building startups, when it's better to build something by all using production tokens instead of using this API stuff?
I'm sorry, say it again?
In Europe, when it's better to build something on the own, I mean, it is AI in a startup instead of using existing.
I see. Yeah, so the question is, when is it better to build your own AI instead of using existing cloud services? I would say that, if you've collected a lot of unique data, one of the things you can do with AI now is transfer learning. So you can build neural networks that can be bootstrapped on other systems that have been built. A lot of the computer vision works like this. You're trying to build a computer vision system to recognize, I don't know, dogs versus cats or something. Whatever you're trying to do, maybe trying to recognize different kind of dog breeds. And you have a specific kind of data that you've collected. You can bootstrap it using some of the open source neural networks that have already been developed. In computer vision, this is very common, and it's going to get you a long way. With natural language processing, it's just starting. It appears that this might be possible with natural language processing, dealing with text and language. It's not entirely clear that it works technically. I mean, I can say it also depends on, really what you're trying to go after. Do you really need to do it, and how quickly can you deliver based on how much funding you have? When we were at Aardvark, even though we were building everything from scratch, we had to do all the AI and machine learning in Ruby. I had to do it in Ruby. Does anybody here program in Ruby? No, let's see, there you go. So I had to do it in Ruby, one guy, my guy, because I had to teach it to you. Oh, over here. You had to do all the machine learning in Ruby. And it was brutal. And still even then, it would spend weeks, at 4 PhDs, spend weeks trying to do this. You still have to get turnaround. So the first machine learning product we built at Aardvark, we had a turnaround in 6 weeks once I started doing it. And putting things together that were just very, very lightweight. And we were using open source tools. So I think that there's a much broader range than use the API or build your own. I think there's a middle ground that you can really take advantage of if you understand the technology well enough. Does that answer the question?
Yeah, this is about how would you think about the strategy when building API using these APIs?
I think using the APIs for...
If you get some just transform and so...
I think using the APIs... So the question is, what do you think about the strategy of just using these APIs that are available? I mean, that's what they're for. And I think the value is you have unique data that you're training them on, and that you or you have some unique business value that you're adding. So you're going after a particular vertical and you're doing something in a way that you can access the customer and you have product market fit. Look, a lot of customers, especially the enterprises, and this is essentially what we do with consulting, it's not that they need fancy machine learning. It's that their workflow and their integration is so old that they couldn't put it into production if they wanted to. We have a client we worked with, the CTO wanted to do some very fancy AI, and the solution they came up with was to use a SQL stored procedure. Okay, that might be good for the next 6 months, that might be okay, but think about all the technical debt that you're taking on by continuing to write stored procedures. You're never going to have it. So the challenge with a lot of companies is just getting that workflow right and getting the product market fit and getting them to adopt the product. And I think you'd be okay if you have something very unique. Was there another question?
Thank you.
Okay, we're good. Okay. Thank you.
Thank you very much.
We